Hello students, this is the continuation of motion class 9 physics. In the previous class we have studied about various types of velocity time graphs. Velocity time graph for uniform acceleration, for non-uniform acceleration and for constant velocity. Once again I am coming to that velocity time graph for teaching you one more point. What are the other uses of velocity time graph? Velocity time graph can be used for determining two things. Number one, the acceleration of the body. If that body has acceleration, then we can calculate the acceleration of that moving body with the help of velocity time graph. Second, we can also calculate the total distance traveled by the body in t second time or in time t using velocity time graph. First of all, look at this graph. This is the velocity time graph for uniform acceleration. If the body has uniform acceleration, then this will be the shape of the graph. Using this graph, we can also calculate or we can also find what is that uniform acceleration of the body, or what is that acceleration represented by this graph. Remember the very important point, acceleration of a moving body is equal to slope of Vt graph. I repeat, acceleration is equal to slope of velocity time graph. And now, what is meant by slope of a graph? In higher classes, you will study more about slope in mathematics. But for your simple understanding, I may say, slope of a graph means by how much degree that line is inclined. Or in other words, we can say, the degree of inclination of a line is called its slope. And how to find the slope of a graph? In order to find the slope of a graph, you have to draw a perpendicular of that graph at any point. Draw a perpendicular. So at any point you may draw a perpendicular. Then slope is equal to perpendicular upon base. For example, the slope of this graph is now AB upon OB. Clear? Slope of a Vt graph is equal to acceleration. Now slope is equal to perpendicular upon base. This perpendicular can be drawn at any point. So I have drawn a perpendicular at this point A. So draw a perpendicular. Then you will get its base also. Now you can stop this perpendicular above some point also. No need to come till the x-axis. You can stop the perpendicular till here and then join the base. Then perpendicular upon base. This perpendicular upon base and this perpendicular upon base, the value will be same. So remember, acceleration is equal to slope of a Vt graph. Slope is equal to perpendicular upon base. Second point, using Vt graph, we can also calculate the distance traveled by the body. So, distance traveled by a moving body is equal to area of the geometrical figure enclosed between the Vt graph and the corresponding axis. Or in short, I may write area under the graph or area under the Vt graph. So distance traveled by the body is equal to area under the velocity time graph. For example, let us see, this is the graph, VT graph of a body moving with constant velocity. This is the graph of body moving with constant velocity. Suppose we have to calculate the distance traveled by the body after any particular time. I am taking a time t here. Maybe 5 seconds, maybe 10 seconds, whatever it can be. After time t second, what is the distance traveled by the body? So, it is written area under the VT graph. In order to find the area under the VT graph, at t second, you may draw a perpendicular till the graph. Now you can see a geometrical figure is formed here. What is that geometrical figure? OABC is a rectangle. So, distance traveled by the body after t second, this is the time axis. So, after any time t, you will get a rectangle in this case. Area of this rectangle will be the distance traveled by the body. We know that area of the rectangle is equal to length into breadth. So, this is OA into AB. OA value will be taken from x-axis, AB will be taken from y-axis, or we can say OA into OC, length into breadth. So OA into OC will be the distance travelled by the body in t second. Now coming to this graph, if you are asked to calculate the distance travelled by this body is moving with uniform acceleration, then again area under the VT graph. After time t second, suppose you have to calculate the distance traveled. So at t second, you may draw a perpendicular. This time you are getting a right angle triangle. At t second, you have drawn a perpendicular to touch the VT graph. Now, a right angle triangle is formed here. Triangle OBA. What is the area of a rectangle triangle? Half into B into H. So half into OB into AB. The value of OB can be taken out from x-axis. Value of AB can be taken from y-axis. So here distance travelled is equal to half into OB into AB. Now look at this graph. This is a special graph. We have not discussed about this graph in the previous class. The shape indicates it is also like uniform acceleration. But this body is not starting from zero. That means when we started watching this body was already in motion. So its initial velocity is this. When this body was moving with certain initial velocity, we started watching that body. That's why this graph is starting from a point little above the velocity graph. So, this body is not starting from rest. This is 0 second time. At 0 second time, the body had some initial velocity. Now it is moving with uniform acceleration. So, this is the VT graph of a body which is moving with uniform acceleration but u not equal to 0. For this body, its initial velocity u is not equal to 0. Now if you are asked to find the distance travelled by this body after time t second, again at t second you may draw a perpendicular in the graph. Here you can see a geometrical figure is formed here also, but this is a trapezium. OABC is a trapezium because this has two parallel sides and this is the distance between them h. This OC and AB are the parallel sides which is represented by B1 and B2. And this is the perpendicular distance between the parallel side. which is represented by h in mathematics. So, area of trapezium is given by the formula half into b1 plus b2 into h. In this case, distance travelled by the body will be equal to area of trapezium OABC, half into b1 plus b2 in bracket into h. So this is the formula to calculate the distance travelled by the body. So there are 2 points to be discussed. Acceleration is equal to slope of VT graph, and distance travelled by the body is equal to area enclosed under the VT graph. Now we are going to use these 2 points in the next topic, that is deriving equations of motion. Now the next point is very important. There are 3 equations of motion. As long as you study physics, these equations of motions are very important. These equations of motions are derived by Newton. So these equations of motions are also known as Newton's equations of motion. The first equation of motion is V is equal to U plus AT. This first equation of motion is also known as equation for velocity-time relation. Equation for velocity-time relation. Normally it is known as first equation of motion. It is also known as equation for velocity-time relation, and the equation is V is equal to U plus AT. Now, second equation of motion is S is equal to UT plus half AT square. S is equal to UT plus half AT square. The second equation of motion is also known as equation for position-time relation. Equation for position-time relation. And the third equation of motion is V square minus U square is equal to 2AS. V square minus U square is equal to 2AS is the third equation of motion. Third equation of motion is known as equation for position-velocity relation. Equation for position-velocity relation. Now, what are the meanings of these letters? V stands for final velocity, U stands for initial velocity, A means acceleration, T means time, S means distance travelled. So, all over these 3 equations, the symbols are U, V, A, T, S. U for initial velocity, V for final velocity, A for acceleration, and S for distance travel. Now we are going to derive all these 3 equations of motion one by one. There are 2 methods for deriving equations of motion: geometrical method and algebraic method. In your syllabus, it is geometrical method, or with the help of graph, we are going to derive all the 3 equations. Now we are going to derive the first equation of motion, that is V is equal to U plus AT. For proving the first equation of motion, we are using the first point that was discussed just now. Acceleration is equal to slope of VT graph. Acceleration is equal to slope of VT graph. This is VT graph of a body which is moving with uniform acceleration, but initial velocity is not 0 because this graph is starting from a point above 0. So this is the graph of a body with u not equal to 0 but moving with uniform acceleration. Same graph will be used for proving equation 2 also, 3 also. Now I am going to draw the slope of this graph to derive the first equation of motion. Now I am drawing a perpendicular at any point. At any point you can draw this perpendicular. I have drawn. Let it be A, let it be B, let it be C. But this graph is not starting from x-axis. This graph is actually starting from this point. So we require the base only up to here. So I am naming O, A, B, C, let it be D. Now what is slope of this graph? Slope of this graph is given by perpendicular upon base. But what is perpendicular? BD. BD upon AD. BD upon AD. Now what is BD? BD is equal to BC minus DC. The total height is BC. BC minus DC equal to BD. So I am replacing BD as BC minus DC upon what is AD? AD is equal to OC. Now what is BC? This is the final velocity of the body, because this body is starting from A and has reached B. At B, what is the velocity of the body? This is the final velocity. So BC is final velocity V, and this body has initial velocity U. When we started watching the body, this body was already in motion. So this is the initial velocity and this is the final velocity. Now OA and DC are equal, both are U. So coming to substitute the values, BC minus DC means BC is V and DC equal to OA equal to U. Now what is OC? OC is the time taken, that is T. Now we have studied that slope is equal to acceleration. So we got A is equal to V minus U upon T. Now cross multiply. V minus U is equal to AT. V minus U is equal to AT. Taking U to that side, V is equal to U plus AT. So this is the derivation of first equation of motion. We are using a graph of uniform acceleration whose U not equal to 0. Now we are using the property slope is equal to acceleration. Slope is equal to perpendicular upon base, that is BD upon AD. But BD equal to V minus U and AD equal to T. Cross multiply, shifting the terms here and there, we got the first equation, V is equal to U plus AT. Now we are going to derive second equation of motion. Second equation of motion is S is equal to ut plus half at square. For deriving the second equation of motion, we are using the second property that was taught just now. Distance travelled by the body is equal to area of the geometrical figure formed under the VT graph. Distance travelled is equal to area under the VT graph. So we are using the same graph for the derivation of this second equation also. Distance travelled is equal to area. Suppose we are going to find out the distance travelled by the body after time t. I am taking this as time t. Time is up to you. We can calculate the distance travelled by the body at any time. So whatever is the time, at that time we will draw a perpendicular till it touches the graph. Suppose this is time t. Say you are asked to find out the distance traveled by the body after 10 seconds. So if this is 10, at 10 we will draw the perpendicular. So after t second, we have to calculate the distance traveled by the body after t second. So at t second I have drawn a perpendicular that is touching the graph at this point. Now I am again taking OAB. Now this is the geometrical shape that we got. OABC is a trapezium. So distance traveled by the body in time t second is equal to area of trapezium OABC. Area of trapezium OABC. Now we know the formula for area of trapezium is given by half h into b1 plus b2. Area of trapezium is given by the formula half h into b1 plus b2. What are b1 and b2? This is called b1 and b2. So what is b1 here? U. What is b2? V. What is the height of this trapezium? OC. What is OC? T. So half into h of this trapezium is OC. B1 means OA. B2 means BC. Distance travel, the symbol for distance travel is S. So S is equal to half into OC means T. OA means U. BC means V. So we got the formula S is equal to half into T into U plus V. Now here we are going to use another substitution. In equation number 1 we have proved that V is equal to U plus AT. So I am going to replace this V by U plus AT. So it becomes U plus AT, which is equal to half into T into 2U plus AT. Half into T into 2U plus AT. Multiply 2U and AT by half T. Half T into 2U, 2 got cancelled, it is UT. AT into half T, half A, T into T, T square. So we got S is equal to UT plus half AT square. Please look at the derivation once again. Distance travelled is equal to area. Here the figure formed is a trapezium. Area of trapezium half h into b1 plus b2. H means T, b1 is U, b2 is V. Then we have replaced V is equal to U plus AT. So we got S is equal to UT plus half AT square. This is second equation of motion. Now we are going to derive the third equation of motion, that is 2as equal to v square minus u square. For this, we are using a substitution again from first equation of motion. First equation of motion is v is equal to u plus at. From this first equation of motion, we are making a substitution for t, time t. So, taking u this side, v minus u is equal to at, or t is equal to v minus u upon a. So we got a substitution for time t from first equation of motion. T is equal to v minus u upon a. I am keeping it as equation number 1. Now for deriving third equation of motion, we are using the same method as we have used in second equation of motion. Distance travelled is equal to area of trapezium OABC, and area of trapezium is given by half h into b1 plus b2. H means OC, b1 means OA, b2 means BC. So we got half into OC into OA plus BC. Now I am putting the values. Distance travel means S, half into OC means T, OA means U, BC means V. This time we are substituting for T. In equation number 1, we have a substitution for T, that is V minus U upon A. So here I am putting half into, in place of T I am going to put the value V minus U upon A. V minus U upon A into U plus V, or I am writing it as V plus U. The value of T is substituted from equation number 1. Now it is half into 2 and A are in the denominator. I am taking it together. 1 upon 2A into V minus U into V plus U. What is V minus U into V plus U? In mathematics you might have studied A minus B into A plus B equal to A square minus B square. So V minus U into V plus U become V square minus U square. So this will become V square minus U square upon 2A. Here we have S. Cross multiply. 2AS is equal to V square minus U square. This is the third equation of motion. So somewhere it is very similar to second equation of motion. The only change is that this time we are substituting for T from equation number 1. From first equation of motion we have made a substitution for T and we are using that substitution here. So this is the derivation of third equation of motion. I hope you understood today's classes. So please study and practice well and ask your doubts in the comment box. So take care. Bye bye.